Welcome back, everyone. We're going to be solving LeetCode 1189, maximum number of balloons. So we're given a string text, and we want to use the characters of text to form as many instances of the word balloon as possible. We can use each character in text at most once, and we want to return the maximum number of instances that can be formed. Okay, so balloon only occurs once in our example 1. Balloon occurs twice in example 2. Okay, so we could simply just loop through our string and count the occurrences of each letter if it's in balloon. And we'll have to divide L and O, the occurrences of L and O, by 2. And then we should be able to return just the minimum of, the bottleneck of the occurrences of B, A, L, O, or N. So how do we do this? We can do this with a counter. So we could import counter from collections, and we'll create that. We'll just call it counts. We'll say counter of our text. So what's that going to give us? That is going to give us this counts. All right, so now we have the frequencies of the characters within our text string. So what can we do now? Well, we know we're going to have to divide O and L by 2. So let's do that. We can do that by saying counts, not dictionary. Counts of L is going to be divided by 2. And counts of, what do we have to do? O divided by 2. And then we should be able to return the bottleneck now. So we can do that with counts of B. All right, we have to count the number of occurrences of B. We'll also have to do it for A, L, and O, and N. B, A, L, O, and N. So this should work. Let's run it, find out. Okay, so we do pass all 3 test cases, submit. Does work. So what is the, actually let's go back. So we could optimize this some more, but the runtime is going to be O of N, right? We're looping through every letter, every character in text, and creating a counter for it. That's going to be O of N. And then this is going to be an O of N runtime as well. So what is our space complexity? Our space complexity is essentially going to be the length of the counter that we're creating, right? So we can optimize this counts.length, right? Because let's say we have a string of, I don't know, 1,000 characters, but there's characters in it other than the characters that are in balloon. So we could, let me just write this down here first. It's going to be counts.length for the space complexity. So what we could do instead of doing this is we could import a default dictionary, and we will say default dict, and it's going to be integer. Then we can loop through our text and grab all the characters that are in balloon. So for character in text, if C is in the balloon characters B, A, L, O, and N, what are we going to do? We are going to increment counts of character by 1. And then we'll still have to divide the occurrences of L and O by 2. But this should also work. So we'll run this, pass all 3 test cases, and it does work. So Now it's still the same space complexity, but it's always going to be the length of balloon in this case instead of the length of our input string. So that'll do it for LeetCode 1189, maximum number of balloons, and I hope to see you in the next one.